Hey guys, welcome back to the channel. This is Nate with the Code with Nate channel. Today we're going to go into how to deploy an SBT Scala Play application onto Amazon EC2 container service. And it's going to be really quick, which is cool because I've already done all the work. I'm just going to go over all the steps to creating your deploy pipeline so that you can do this for your app. Now, this should work for most Scala Play or modern Scala Play distributions, I would think. But if not, if you run into any snags, feel free to post a comment below and I will address that quickly, usually within a day, sometimes within an hour. So thanks again for watching, guys. Again, if you like the content at the end, please subscribe. And thanks for watching, guys. Let's get into it. Alright, so I've got a standard Scala Play application, and the version number's in the description below. I think it's 2.6 for Scala Play, and running 2.12 for the version of Scala. The first thing you need to do when building a Scala Play app is, since we're distributing it with Docker, is we are going to create this Dockerfile, and I've created it in the root directory of my project. You can choose to create that wherever you want, obviously. But the idea is that we're going to extend this base image, Scala SBT by HC Burger here. This is a free to use base image and that sets up everything we need to run Scala. And at this point, we're going to go over how this file is created in a second, but we're going to copy our executable zip file that SBT is going to create for us into the Docker, our Docker image that we're going to create. And then I've also copied over production configuration. This will be whatever configuration you use. You don't need to do this if you don't have production configuration, but in my case I do because I point to a different database. And this obviously, this is the project name right here. At project name and version, this might be different. Well, this will obviously be different for you. So you'll have to change this value. And that goes for this instance of that value, and this instance of that value, and this instance of that value, and also the executable name. So the other thing this does is this unzips that zip, and I list out the contents of the bin directory of that zip, of those unzipped contents, because that's where the executables go. That's where Play puts the executables that will actually run your application. And I set the worker, which is the working directory, to the unzipped directory. And then all we need to do is run, because Scala Play creates this executable for us, bin, and then whatever the executable name is. You'll get this name by viewing the output of this ls command here when you're running Docker build. And I'll show you how also to find that, because we're going to inspect the contents of this zip file that we're about to create. So I want to build this zip file, there is an SBT task that we can run. So I'm going to jump over to this terminal here real quick to create the, let me make sure you can see this, to create our zip file that contains the executable for Scala Play. You run this task's dist. So run SBT dist. If you have a multi-project SBT setup, you might need to do project 1/dist or something, and that goes ahead and creates an executable with everything you need to run your Play app, which is pretty cool. This is over in the official Play documentation if you want to read into that. So this sbt dist command is going to create this file here, target universal, and then whatever your project name is, .zip. So go into the target directory after this command is run, and look into universal, and there it is. You can see the zip file that's been created. And so this is what this is the file name that you need to insert into here, here, and here in your Dockerfile. Oh, and also here. And then you're going to unzip the contents locally at first to see what's inside. So I think, I'm not sure if I can do that from IntelliJ. So we will jump over to terminal real quick. So I would go into target universal. This file was just created here, and I should be able to just run unzip on that. I'm going to have to replace all of them because that directory is already there. That's going to go ahead and create this directory here for you, and you can find the name of your executable. It's going to be in here. So if you see, I've got these, basically there's 4 different executables created here, and then I think these are Windows counterparts if you wanted to run your executable on Windows. So if I want to run my API, which is called Udemia, and this is defined in the build SBT, I need to run this executable, and that is why this the command that the Docker image runs is bin/udemia4. That comes from this right here. Okay, so we've got our Dockerfile built. Now I want to automate the actual running of this Dockerfile to create the image. And to do that, I'm going to close this now. I created this build.sh file. Now, build.sh is going to do a few things. It takes 4 steps here, and I've echoed out what the steps do. This is going to be something that you guys might want to copy or whatever. So what it does is I've grabbed a timestamp, and we'll use that in a second here. I run SBT dist. So we just ran this manually, but to execute our build, we don't want to have to run that manually every time. We only want to run one command to build it, and so as part of that, we're going to run SBT dist, which is going to package up our play application and create that executable. Then we're going to run docker build, and we need to specify a tag. This you could change to whatever your purposes are. So if you've got another app name, you would call it whatever your app name is. So it's going to run docker build, and it's going to tag that with its college web here. And dot, don't forget the dot there to run in this directory. Then we are going to tag, we're going to create remote tags. And this is going to point to an Amazon ECS repository, which I'll show you guys how to create in a second. You guys are going to have to replace these values here. All instances really of this, you're going to have to replace with whatever the URL is for your ECS repository. I guess this whole string here. And then also you're going to have to replace this tag with the tag here. So yeah, so we're going to tag it with latest, and then we're also going to tag it with timestamp. This timestamp that we created up here, and this is going to allow for us, so our auto deploy is going to work with this latest here eventually, and our task definition in ECS is actually going to deploy the latest version. However, we want to be able to roll back sometimes, so I've created this tag also that has the timestamp, and I'll show you what that looks like in just one second. And then we just push both of those tags up, so these values are going to be the same as these tags we created. We just need to push those tags up to our ECS repository. So I'm going to show you what the output of this looks like, and then we'll jump over to AWS to show you guys what needs to be done in AWS. So I'm just going to run build. Sorry, I need to go back into my project directory here, and I need to run bash build.sh, and we see some this is the debugging output that we're echoing in our script. And so, I mean, if you took away the echo lines here, the script is really simple. It's only 1, 2, 3, 4, 5, 6, 7 lines of real code that's doing anything. The rest is just debugging and comments. So, yeah, we can see, let's go up to the very top of this input to output here. So we're creating, this is just a debugger to tell us that we're creating it. We're going to create the Docker image. That's the Docker build command. Creates that image, and then we're going to tag it and push those tags. And then you see some output of the Docker push. So let's go and see. And it says it'll show us the tags, I think, maybe. Yeah, see, so we can see our tag here. So it's going to tag our image with both latest and this timestamp here. So let's jump over then to AWS and get into how we create this repository that we're going to push to, and then we'll go over how to actually deploy this image once it's been created. Okay, so the first thing we're going to need to do is create a repository for our images, and I've already done this. You can see this repository name here, College Web, but you're going to need to click on this Create Repository button, and we'll just create a new repository for now, or whatever, college demo, and you're going to be using this URI, but we can get that in the next step. So go to next step. That's all it took to create the ECS repository. You're then going to need to run these commands here. Don't forget to log in to your AWS. You might need to install, first of all, this AWS command line interface, and it looks like there should be some documentation. Search around if you need it to install the AWS command line tool. And then you're going to have to run configure to log in. So you're going to need to get your AWS access key and secret key and log in using this AWS configure command, just like that. I'm not going to run it because there's some private information that outputs when you run it. So after that, you're going to run this command here, and I've annotated in the build script here that you should do that, and then you need to execute the output of that command. So you're going to copy, and it goes through the steps here. So you can really, I mean, you can plug this in to that build.sh file that we created, and you're almost good to go. So what I would do is I would copy, let's see here. Basically, we want to copy this string here, maybe all of this. Yeah, let's see, like we want to change our project name to college demo, and then the repository URL to here. So you'll be able to figure that out just fine, I think. Let's take one final look at the commands here. I'm going to get rid of, no, I don't want to get rid of the echo content. I wish, let's see. I'm going to comment out the echo line so you can see what the executable code is real quick, just so it makes it easier to copy over. So this, see how this Docker build command maps to this command here. We're going to just copy this command, replace it there. Well, that didn't quite work, but you get the idea. Copy the tag here to whatever the tag changes to, and then you're also going to have to copy over this URL, and that corresponds to this right here. So once you've got that done, basically we need to go and, or I guess let's go, and I'm going to show you what this looks like once you push your container images to ECS, and that looks like, let's go back. It looks like this. So you push up the images. Wow, these images are huge. They're each 500 megabytes. You need to figure out a way to get those down. You push the image and basically it tags them for you. So I'm going to create a new version just to show you guys what this might look like. So let's just make one change in our my course controller here. I'm just going to print line hi, and going to run that build script that we created, which is going to run Docker commands to build and push our container up to ECS. And that's going to create a new tag for us. It's also going to create a new, it's going to create a new image up here and assign that the latest tag, and then it should also get a timestamp tag. So it's running. It's taking a little longer this time because the spt dist command has to do more work now that we've actually made a change. And here we go. It's running. All right, let's take a look and see. For whatever reason, time is it now? It looks like maybe our I think that maybe the tagging is not working quite right because we see that we just added that tag to this same image here, even though it's a new image, or it should be a new image. So I think what I'm going to do is actually tag it. Let's see if we can do this. And in this way we can push up, we're going to tag it locally with the timestamp instead of with latest, and see if that allows us to create a new image here. So I'm going to run build sh. I want to make sure that that we're getting a fresh image up here every time. Let's take a look at the digest really quick. So this should change for latest because we're pushing up a new image, at least in theory. Does not exist. Air response, Damon, no such. Just looking through my Docker images right now to see what tags we've created here. We did create one. Let's see, it complained. It complained that it could not find this image here, but we can see. Oh no, it didn't get created there, huh? Let's see what else is going on here. I'm going to try then and close that in some quotes here. If this doesn't work, we'll just move on and talk about deploying latest. And I'm going to have to figure out why rollbacks or why the tagging of the timestamp's not working correctly. Yeah, so we're going to run build one more time. So that's building. Let's see. So SBT dist ran. Now we're building the Docker image. And let's see here. So no such image. It says it's not working. But 0402. It's weird. Huh. I wonder. I kind of wonder if we can't do that. Oh, man. Wonder if. I don't know. So I'm going to keep playing around with that in the background, guys. But anyways, let's we've definitely pushed up our image here. Let's just take a look. So what you're going to see is that you've got a image up here in your repository with the tag latest, and that's what we're going to deploy. And you would use these to roll back here. You would roll back to a specific version, but we're going to always deploy latest. So let's go take a look at how a task definition looks for that. So you're going to go to the task definitions tab over here and create a new task definition. But I'm going to open up my existing task definition to show you what that might look like. And I configure with JSON usually because it makes things a little easier to see, I think, than using the interface in AWS. So you click this configure JSON after you've created one, and basically I'm going to trim out some of the fat here so you can see the important configuration settings. Use the default config and then modify it so that it fits your needs. But let's see here. There's not really that many important configuration options that you need to change to get this to run. In fact, I'm even going to try and save this if we can. Let's see here, family call. Yeah. So the important things really that you're going to have to change yourselves are the host port and container port. So this is the port that your SBT, that Scala Play is running on. So I think by default that's 9000. And typically you would have your host port 9000 forward to that container port 9000, but you can do whatever you want. I've got Scala Play running on port 9191 because I set the http.port option in my play config. But yours may be different. You're also going to want to set a name here for your task definition, for that container, definition. And then you're going to have to plug in, this is the same tag. This is the tag of your Docker image here that you created, and that is in your build right here. Let's see if that worked. So the other settings you may need to change are CPU and memory reservation. You're going to be able to see how much CPU and memory you have free if you head over to oh, cool, that works. If you head over to, oh, but it creates all the default values again for you, your cluster here. So if you head to the cluster, you can see how much memory and everything you have available. So to create a cluster, I think I have another tutorial on here about deploying PHP Symfony to ECS, so you can check that out, but the wizard for this is pretty straightforward. So if you don't already have a cluster, you would go through the process of creating a cluster here. You name it, assign some instances to it, or let it create instances for you. It's really just one page and it creates the whole cluster for you. Make sure you throw it in a VPC that you're going to be able to access. That's something to pay attention or keep in mind. But for this tutorial, we've already got a cluster created for us. We've gone over how to do this before. So we're going to go into our cluster here, and I'm going to delete this service just to show you how to get this running, I guess. So I need to update that service first. To delete a service, you have to set the number of tasks to 0 in AWS. And I'm going to delete that service altogether. So we're going to create from scratch this service that's going to use our task definition to keep our Scala Play app running all the time. So just head here to the clusters tab, you get into your cluster, and then you're going to click create. And create's going to guide you through creating that. So I'm going to the latest edition of my task definition here. Whatever yours is called, you want the highest number that you just created. It might be 1 for you because we just went over how to do this. You're going to name your service, and I call it College Web because it is the API, or maybe we'll call it College API because it's the API for this college app I've been working on. We only need 1 instance of this running right now. If we were in production, I would run like 3 instances of this application, and our load balancer would distribute the requests to that to the servers for us, round robin or whatever. These default settings are fine. Look into that if you want to learn about how to auto scale on things based on the health percentage or whatever, or how to give yourself CloudWatch alerts when things are going hoary. I leave this setting default. Okay, the next step is you're going to have to assign a load balancer to it. Use the application load balancer. It's a new way to do it. I think they're probably going to phase out classic load balancer eventually or whatever. They're certainly not recommending that you use them. So select application load balancer, and you may not have one created yet. So we're going to go over how to create an application load balancer right now. So to do that, you're going to have to go into EC2. And EC2 has this tab over here called load balancers, and we're going to have to create one, and I'll create one let's just call it college API. It is internet facing because we need to be able to access this from anywhere. And we're going to listen on port 80 because that's the standard HTTP port. And the load balancer is going to forward port 80 traffic to our containers on port 9191. Anyways, we're going to choose a VPC. I've only got one VPC here, fortunately. And we need to make sure that it's in the correct subnet for our application. It needs to be a public-facing subnet. So I go ahead and click, let's see here, what do we need to do? Or it needs to be in the right availability zone, sorry. And our subnet is in this 2B, or I want it to be in this 2B availability zone, which is where the EC2 image is for our cluster. And that is right here. And so I can see that's in the availability zone 2, or no, sorry, it's not that one. It's this one, and it's in 2A. So I want to make sure we're in 2A as well. And I also just select 2B because you need to select 2. I think at least 2 subnets must be specified. Oh, we need to specify the exact subnet here. So I'm grabbing the subnet from my EC2 instance. So that's going to be this one here. Copying that value here. So we're going to select that one and then random one. No, not. I don't want private. Public. Okay. So next thing we need to do, we need to configure our security groups. We're going to go in here. You might need to create a new one. You can go ahead and do that. All you need to do is allow port 80 to it, so that's fine. We're just gonna let it create a new security group. I'm gonna call it delete me. This is for a demo, so that I delete this later because otherwise it's gonna clutter our AWS. Gonna go ahead and click configure routing. Target group. So let's see here. We're going to create a new target group that's eventually not going to be used, I think, but we'll see. Maybe it will. And we're going to call it college API servers or whatever. The target group port is going to be 9191. And this is because our task definition and our, well, Scala Play is running on 9191 for me. It might be 9000 for you. Keep that in mind. Target type is going to stay instance. And then if you have a health check, add that here. What I do to, if I don't have a health check, I go to advanced health check settings here. Leave everything the same here, but we're going to allow for 404s. Usually you would want to define a health check, like /health on your service that just returns status code 200. So that the server knows that your app is running, okay, or sorry, so that the load balancer knows that your app is running in a healthy fashion. But if you don't have that, this little hack I find works pretty well, and it's that you just include 404 here. So it's 200, 404, and that way, as long as Scala Play is returning a 404 code, you can say like, well, at least Scala Play is running, even though I'm not able to hit a route. You could also go and enter a path here of something that you know is going to return a 200 response code, and that's what I'm going to do in this case, so I don't have to look at advanced settings here. I'm going to hit this endpoint, which I know exists, for the health check. So next I'm going to go register targets, and I'm going to register my ECS instance as a target here. This is the instance that's inside of your ECS cluster that you created, but hopefully you created. And click Add to Registered. Now we click Review. I'm just going to scan over this stuff and make sure it looks good. So we created a new target group that listens on port 9191. That's all good and fine. And we're looking for success code 200 on this path. That's going to tell us that's going to tell the load balancer that app is running if it hits this endpoint on port 200. We've got our target here. Everything looks good. Let's create it. Great. So our load balancer has now been created. And I'm going to go real quick and just make sure. I want to make sure after I deleted that service that AWS cleaned up that running container, and it did. Okay. So now we're back in our ECS create a service wizard. And it's got this nice refresh button here. So we're going to click refresh. And now we can see this newly created college API load balancer that we created. We want that. You're going to need this to be set to ECS service role probably. I think that's set by default. You may have to create a new role. In this case, that would be fine. It would create a role with the right IAM permissions for you. And then we're going to click, so this is our container and our task definition. We're going to click add a load balancer there. And we need to configure the service to point at our load balancer properly. So the listener port, and this is the listener port, we're going to go ahead and just select 80, which we've already set. And we are going to select our target group that we created. And we're going to let the health check, we're going to use all the configuration we specified in our target group here. So we don't need to do any more configuration. We just click next step. Leave the default auto scaling here. If you need to do auto scaling, this would be where you would configure that, but we don't need that for now. Do a quick review. We are forwarding port 9191. Port 80 traffic to the load balancer will forward to our container port 9191. Let's go ahead and create that service. It's going to go ahead and create, what is this, an IAM policy, I guess? Oh, we gave the ECS role permission to mess with the load balancer, I guess. I don't know. And then our service is created. So let's go ahead and click this view service here. So we can see our task is running here. And this whole process is fraught with peril, guys. So if you guys run into any snags, feel free to message me or leave a comment below, and I will happily help you figure out what's going on. Because just to figure out how to do this deployment probably took like 4 hours or something for me. And I've done this several times with other technologies, and it's just every time it's pretty difficult. So it looks like we can go to our events tab here, and it says service college API started one task. So I think our task is running just fine, which is pretty cool. So what I want to do to test out that that's running is I'm going to go over to the load balancer here that we created. And I'm going to find this DNS name right here, copy that, and I'm going to curl my health check from here. So I'm going to curl, that's the load balancer DNS, / and we called it courses ENG 101. And there is our course. So that is our Dockerized application running here. And it's returning response code 200, you can see. So that lets our load balancer know that that's healthy. We have now deployed our Scala Play application in Amazon EC2 container service, so that's pretty cool. I'm glad that went smoothly. Sometimes it doesn't go quite so smoothly. I've had to reshoot ECS videos before because of how complicated it is. So one more time, I'm going to go over what it takes to push a new version of our service here. So we're going to run then hold on, I actually want to figure out how we can build Docker build with custom tag. Let's see. Yeah. Come on. There's some code here. See some examples of tags. I don't though. Okay, there it is. So it's colon. Yeah. I think we were doing this right. I don't know what's going on. Anyways, to deploy a new version, all we have to do is run that deploy script, or sorry, the build script that we created, which is going to package up our an executable of our Scala Play application. It's going to run the sbt dist task. Then it's going to build a container around that executable that has all the necessary dependencies like Java installed. And after that, it is going to tag that Docker image and push the image to Amazon ECS Repository for us. And I'm still having issues with the tags. I don't know what the deal is, but it's still pushing latest up just fine. So at that point, I would go ahead and go into my cluster here, and to get your task definition, see our task definition points to the latest version. So to deploy a new version, we just go into our service here, or sorry, that's not the right one. We want to go into College API here, and we need to update this, or sorry, no, we need to go to our tasks here and click on the running task, and I gotta, let's see, I'm blocking it over here. Let me resize the window real quick. You need to click this stop button here. Maybe it would make more sense to go like this. This stop button, and that's going to stop your task. Confirm that you want to stop that task. And then it's going to just run a new task for you. So we stopped this task, 50E, and it immediately started a new task for us. And we're going to be able to see that running if we run that same curl command here in a second, I guess. It's got to get the health check. Basically, if we take a look, I think it's going to think we're unhealthy right now. We don't. That's on the load balancer is going to know we're unhealthy. Maybe. If we had more tasks, more instances running, that would be better. So right now our health check is probably failing because Scala Play kind of does take quite a while to run. But if we look at our, let's see, our load balancer here, the load balancer is going to know we have an unhealthy instance running there right now. And let's see, monitoring. Thought there was a healthy. I'm going to SSH into that container really quick and see if that's running. So it says it's running. And if I check out Docker logs F, it says we're listening on port 9191. And if I curl my localhost 9191, courses, ENG 101, I can confirm that, yeah, the service is running, and I can hit it with curl. So that's good. It's just taking a minute here for the load balancer to register that healthy instance, I guess. Yep, so it's running. It's just taking a while to register with the load balancer, I guess. So that's fine. So that's how you deploy a new version. Anyways, I hope you guys liked this video. If you did, please click subscribe. If you've got any feedback, leave some comments below. Feedback's always cool. I also do user requests, so if you have anything specific, any technologies you want me to go over, or deployment processes, programming languages, or whatever, I would be happy to go over those in another tutorial. So as always, guys, thanks a lot for watching, and I hope you guys can use this for your benefit. Anyways, have a good day, guys.